Perfect. Louisa, thank you very much. Thanks very much for the opportunity to give a little synopsis of what we've done here at Stewart Brewing over the last really sort of like 2 or 3 years with regards to carbon capture, which really falls part of our entire philosophy on our drive to net zero and how the brewery is coping with the challenges that the planet is faced with. Just to give a little background, Stewart Brewing, we're a small brewery. We produce mainly for customers in and around Edinburgh in central Scotland. We have been going for quite a long time. We've been going since 2004. So we are officially next year 21. So 21 years, and through all of that time has been quite challenging, but never so much as the last 4 or 5 years. And one of the reasons that we've done what we've done is really in response to how we would like the brewery to develop, but also in response to challenges that we've been faced with. So just to give a little bit of background on, with respect to carbon dioxide, we've always had a long-term interest in carbon capture. Joe and I, my wife, who set up the business with me back in 2004, actually met on a sustainable development degree whilst we were at Glasgow University. So when we started Stewart Brewing, my original degree was brewing, we always had an interest in brewing sustainably. So this has been on our minds for a long time. However, for a brewery of our size, the technological solutions really weren't there in the early days. So we use, at the moment, we produce about 20,000 hectolitres of beer. So we're not a tiny craft brewery, but we're not the biggest. We use CO2, as Steve alluded to, mainly for processing in the brewery, for tank purging, the removal of the dreaded oxygen. We don't want anywhere near our beer. CO2 is a great shield gas for preventing beer degradation. Also use it for some motive forces in the brewery for tank-to-tank transfers, but mainly for our can line and our bottle line operations, and for dispense gas. We have a refillable growler station here that we supply about 18 to 20 taps for filling into customer refillable growlers. So we've got multiple uses for CO2 across the business. So talking about purchased CO2, we buy around about just short of 35 tons a year of carbon dioxide. I was quite interested in the prices and the figures. I mean, CO2 has done nothing but go up in price. And I think originally, way back in 2016, we were paying about £350 a tonne. It went up to closer to £1,000 a tonne around about 2021. And it became quite a substantial cost for us. Not only was it a substantial cost, but it was also delivered in 34 kilogram cylinders. These are not the small cylinders that pubs use. They tend to be what's called size B cylinders. These are big size K cylinders, and they're pretty hefty. And there is a manual handling impact involved in that. And we were manual handling over 1,000 cylinders a year of 34 kilogram CO2 cylinders. So we're spending just north of £30,000 a year at this time on carbon dioxide. The big issue was the interruptible supply nature of it. So the last sort of 4 or 5 years is kind of all quite hazy on exactly when the supply constraints hit. But certainly the worst from our point of view was in 2021, which, bouncing back from the pandemic, when the majority of our on-trade was closed, we thought, don't worry, we have a can line. We'll be able to supply the majority of the beer into package. And so we had a huge shift from large pack into small pack for the brewery. The two things that came up to bite us were there was a can supply and shortage. So it was very, very difficult. And we were kind of at the bottom of the pecking order when it came to securing enough cans to put the beer into. However, once we'd found the cans, and once we had secured some contracts, we were then told we wouldn't have CO2. Not only was the CO2 going to go up in price, but in fairness that we weren't going to get any of it. And that was a huge business resilience issue for us. So that was a completely stressful time, and focused our efforts on what we were going to do in regard of carbon capture. Just a little bit about CO2 emissions, and talking about CO2 emissions from fermentation. So this is not to do with any of the other fuels that we use across the business. It's termed as short cycle capture carbon, because the carbon in that is actually captured the previous year through barley growth. It's a natural process, naturally provides fizz and sparkle in the beer, and through fermentation, before carbon capture, we were releasing about 70 tons of CO2 into the atmosphere from roughly 20,000 hectolitres of beer production. And the question that we asked ourselves was, how much of this released carbon dioxide can be captured to offset against the purchase of CO2 into the business? So we came up with a proposal in 2022, and it was along these lines. Basically, it had to fit with our values of the business and along the lines of our ambition for net zero. It had to be cost effective with acceptable payback times. And we opted for two what are called 15 kilogram per hour DALUM carbon capture machines. And we'll talk a little bit about why we purchased two. But as Amy alluded to earlier, all the CO2 is not produced at once, and it's not produced consistently. So we have some small tanks, which are 5,000 litres, and we have some large tanks, which are 25,000 litres. And in order to capture the most amount of carbon dioxide, it was necessary for us to install two machines, which meant that if we have a small lot of CO2 getting produced, we can run one machine, and if we have a big tank fermenting, we can run both machines. Our production manager, who's on the call as well, Sam Russell, did a large amount of work into scheduling and how we plan to capture the CO2 and how it's all produced. Really, in putting two machines in, it enabled us to increase the potential capture from 43% to 66%. So for us, it meant that we had the ability to capture around about 46 tons of the CO2 that we're producing from fermentation. It's hard to capture all of it at the very start of fermentation. The flow is very slow, and it's also contaminated with quite a lot of oxygen. So we generally wait till about day 2 of fermentation to put the beers on collect, and we're really pleased with the harvesting, if you like, of the volume of CO2 that we were getting. In collecting 46 tons of CO2, you'll know that we use 35 tons, so we've got excess CO2 availability. There's some fringe benefits. We reduced the manual handling, improved job safety and efficiency, leading to higher job satisfaction. It also allowed us to introduce bulk system for efficient operations and improve the business resilience. The technology for large breweries, I think, had been around for quite a long time. I seem to remember even Scottish Courage doing this way back in the 90s, but relatively recently available for smaller scale producers. The technology, I think, is similar to the other equipments on the market. We collect CO2 from fermentation through a network of pipes and scrubbers. The package machine washes out any impurities. It condenses and removes any unwanted gases, such as oxygen, and removes water. It liquefies it, pumps it into a cryogenic storage tank, and our result is 99.99% purity, odourless and tasteless CO2. We work with DALUM, Danish company, started with Kim Dalum. They were local to us in terms of they were European, and they really understood our needs, and they developed solutions for us and worked with us to make sure that we fully implemented the technology to its best use. I've got a slide here on the financials, which, you know, if put in scale context, our brewery, we sell between £4.5 and £5 million worth of beer a year. So 150k investment for us, substantial, not huge, but still quite substantial. We ended up installing for that 150k 2 of the DALUM machines, but also bulk handling tank and a lot of the collection and distribution systems. There was a lot of work that we put into manifolding across the business. As I said, it allows for 45 tons a year of productive capacity. Essentially, if you strip out the capital cost, the load is electricity. These units use compressors to compress the gas. The rough calculations is about 28,000 kilowatt hours annual load for us. When we installed the machines, we were paying about 50 pence an electrical unit. It's actually come down now to about 25 pence a unit. So we're paying just shy of £7,000 in electrical costs for the units. I will note I've not pulled into the figures, but at the same time as this project, we installed 140 kilowatts of solar PV on the business. That was the other major investment that we made at the time. And interestingly enough, because we start brewing on a Monday, we collect CO2 on a Wednesday through to a Sunday. We, generally speaking, are always producing excess energy towards the weekend because we're not operating the production plant as much. So a large part of the CO2 electrical demand is provided for by the solar panels on the roof, which makes a lot of sense to use that excess electricity in-house. A cost per ton, if you like, I was comparing it to £963 a ton, is just on the electrical cost about £177 a ton, which equates to savings of around about 26,000 a year. So we're paying 150, 26,000 a year savings, about a 6-year payback. We were fortunate to obtain an RSA grant for the numerous benefits and securities and resilience that the system added to the business of roughly 50%. So from the business point of view, it's about a 3-year payback. Phase 2 of the project really involves what do we do with the excess 10 tons of CO2, and we're continuing to work with DALUM to produce a cylinder filling operation. We supply around about 500 independent pubs, bars and restaurants in and around Central Belt of Scotland. Steve alluded to the fact that the market for the CO2 is there is not a lot of competition in this market at the moment. We have some spare CO2. It's sustainably produced CO2, and we are looking to see if we can sell some of that spare CO2 into pubs, bars, and restaurants in our local area, just like the breweries used to do quite a long time ago. So any additional earnings that we get from this project will allow us to invest future in some other sustainable development projects that we've got going on in the brewery. Environmental considerations, the capture, we're preventing the release of 46 tons a year of CO2 to the atmosphere. Previously, there's some calculations that you can do based upon if that CO2 is a byproduct of ammonia production, which Steve had mentioned, or other non-sustainably produced CO2. You are actually removing carbon from the atmosphere. And so if 1 ton of CO2 captured reduces estimated carbon footprint by 2 tons, over the 3-year project, we'll be reducing our CO2 footprint by just over 250 tons, which is a great thing. To happen. Some fringe benefits and learnings. We probably produce about 40% of our beer goes into cask. We're quite a large cask ale producer, which is great because cask ale has a very low amount of carbon dioxide left in it, and so it's a net positive contributor of CO2. So the more cask that we sell, the more CO2 that we've got to carbonate. One thing that we learned was with ambient Scottish temperatures for our bulk storage tank, we needed a larger vaporizer than the one that was supplied. And other aspects that we found, because we use CO2 for motive force to push beer from one tank to another, we can infinitely recapture from the process tanks that have been emptied. The tank is left after pushing beer to the bottling line. It's full of CO2. We can then recapture that CO2 and then liquefy that and use it again in the future. So it's a great system. Just a little bit about DALUM. We were very pleased to work with them. I think we were the first in Scotland to introduce DALUM machine. I think they've installed quite a lot now. There was a brewery down in England called Gadd's, and we spoke to Eddie Gadd, who was very recommended of them. They've helped us with problem solving, maintenance support, and the utilizations of the machines. So for us, CO2 install and carbon capture really has helped drive the business forward and increase its resilience and save some money for future investment. And there's a picture. So we've got a couple of pictures. That's the two machines. In this one, we have a fairly Heath Robinson blue plastic tub that's been replaced with a higher quality stainless steel unit now. So that's the two machines, and that's the bulk tank that we put in. It's a 2-ton tank. Gives us plenty of spare CO2 and some investment in distribution across the brewery. That's really it from me. Thank you very much.
Thank you very much, Steve. No, that was a great overview. Really kind of helps to bring to life the kind of the practicalities of installation, and also why it's important to you as a business. And I thought some of the added benefits are really useful as well, like manual handling, as kind of things that you wouldn't necessarily think of, but actually, yeah, really helpful added benefits.